Hey guys, thanks for watching my videos and sending me all that feedback. It was really encouraging. I thought I'll add one more to the series of videos which I had already done. This is an old problem, and the inspiration came from while teaching my child mensuration. The best part of this problem is that you can attack it in 4 different ways, all of them logical, and you can choose whichever one you want. There's a rectangular garden, 112 meters by 88 meters, surrounded by a path 12 meters width. Tiles have to be laid around the footpath, and we have to arrive at the area of the footpath. Let's solve this problem geometrically. You see the inner rectangle minus the outer rectangle. The inner rectangle dimensions are given as 88 and 112, and the width of the path is 12. The outer dimensions can be arrived at nothing but 112 plus this 12 and this 12. Similarly, this is 88 and this is 12 and this is 12. So, the entire breadth is 80 plus 12. So, it is inner rectangle minus outer rectangle, which is nothing but 136 into 112 minus 112 into 88. Now this is nothing but 5376. As you see, it's quite a large number. Sometimes you can go wrong while solving it. So today there is a formula which is given. But let's try and approach this without the formula. Okay, let's try and solve this problem logically. So what I'm going to do is I'm going to cut this here and here and here and here. So if you see, there are 2 rectangles here and 2 rectangles here, and there is a small square here. In fact, there are 4 here, small squares. So if you see, the area of this is nothing but 112 into the width of 12. And there are 2 such rectangles. These 2 rectangles, it is nothing but 88. Again, the width is 12. And there are 2 such rectangles. This is 12 into 12. And there are 4 such squares. So the total area is nothing but this 12 into 2 is common here. It's 24 into 224, which is 5376. Here, what is given is the inner dimensions, inner length, the inner breadth, and the path size. To generalize, it's nothing but SL plus SB plus, if you see, twice the path into twice the path. Here it's nothing but 2 into 12 into 112 plus 88 plus 2 into 12, which is equal to 5376. So, applying the formula, remember what it represents in each case. Thank you. Now let's see what if the outer dimensions are given. In this case it is 136 and 112 and the path size of 12 is given. How do we approach this problem? So again I'll do the same thing. I'm going to draw here. This represents 136. The entire thing represents 136 and this 112 is represented by here. So I'm going to do something interesting. 136 into 12 represents this entire stretch. And these two will be multiplied, means multiplied by 2. 112 into 12 will represent this stretch, and multiplied by 2 will means both of them included. So if you see these small squares, this is 12 by 12 and there are 4. So in this case the total area of the footpath is nothing but 136 into 12 into 2 plus 112 into 12 into 2. Unlike the previous case, this footpath area, this square, has been counted twice. So you have to subtract 4 such. Area of the path in this case would be, if I take 12 into 2 common, I would be subtracting the area of the path which has been twice counted. So it is nothing but 24 into 224. So to generalize, if outer length is given and the outer breadth is given and the path size is given, bigger length and the bigger breadth and the path size. So it is BL plus BB minus twice the path into twice the path. So in this case it is 24 into 136 plus 112 minus 2 into 24, which is equal to 24 into 224, which is equal to 5376. So to remember the formula is that you have to subtract the path size because it is counted twice over. Thank you.